Let's have a review of rules of exponents. So these rules are actually not new to you, but we are going to have a brief review to kind of help a little bit. So a monomial is a number, a variable, or a product of a number and one or more variables. So basically, if there's not a plus or a minus between your numbers and variables, that's a monomial. 34xy, 7a squared b, or just x, that's a monomial. So let's start with our first rule of exponents. The first one is the product rule. A to the m power times a to the n power. Basically, you add up the exponents. So for example, 5 to the second power times 5 to the sixth power is the same thing as if we added up the exponents 2 plus 6 to get 5 to the eighth power. And we can simplify that further, but the big idea is just we're adding these up. So pause the video and try the next few as you add the exponents. Now let's check your work. We have 3 y's, so that's the same base. Y is the base, and we want to add up those exponents. 4 plus 3. Don't forget, if there's no exponent here, we understand it to be just 1. So we're going to add up the 4 plus 3 plus 1 to get y to the eighth power. Again, over here, we're adding up the exponents, and there's an exponent of 1 after that y. Don't forget to multiply that 7 times the 6, and we're going to get 42 y to the 6. This one gets a little bit more fun because it has more than one variable. But still, we're going to multiply -3 times 5, take the x's and add up those exponents, 2 plus 1. Add up the exponents for the y, 7 plus 6, and we're going to get 13. One big idea here is we only add the exponents if they have the same base. So it has to be the same base. I don't add up the exponents for x and y. I add up the exponents for this x being multiplied times that x. Now, our next rule is the quotient rule. If we're dividing two things with the same base, we're going to subtract the exponents. So over here, y to the sixth power divided by y, understand that's y to the first power. We're going to take the top exponent minus the bottom exponent, and we'll get y to the fifth power. Now try it with these other two. Pause the video for a moment, and let's see what you get. All right, so if you've tried out these problems, we're going to subtract those exponents 13 and 2 to get 6 to the 11th power. And again, we can find out what is 6 times 6 times 6, 11 times. But for right now, we're just focusing on this rule. And this last part, just like before, it gets a little bit more involved. First of all, 10 divided by 15, that's a fraction that can be reduced. Both of these can be divided by 5. 10 divided by 5 is 2, and 15 divided by 5 is 3. So we can reduce this fraction to 2/3. So instead of 10 over 15, I'm writing 2 over 3. And then I'm going to continue with subtracting those exponents. A to the 7 minus 5 power, and B, we're subtracting 9 minus 9 for those exponents. We're getting 2a squared b to the 0 power over 3. Now, we're going to talk about the 0 exponent a little bit more in a bit here, but for right now, we'll just leave that just like that. And speaking of the 0 exponent, let's look at how we get that. So here's our rule. We said 8 to the second power over 8 to the second power. Basically, we would subtract those exponents and get 8 to the 0 power. But what does that mean? Well, if we write it another way, we can see, all right, 8 to the second power is 8 times 8. Okay, and we can write 8 times 8 in the denominator also. We know that when we're multiplying, 8 divided by 8 is just 1. We usually just say cancel this out. And then again, 8 divided by 8 is 1 again. So we basically have 1 times 1. Just 1. Basically, everything cancels out and we're just left with 1. Anything raised to the 0 power is equal to 1 because anything that's divided by itself gives us 1. So basically, negative 3x plus 7, it doesn't matter what x is, we're going to say that this simplifies to 1 because everything in the parentheses is being raised to the 0 power. Now, this one's a little bit different. only the x is being raised to the 0 power. So I'm going to bring down the 8, and it's 8 times x to the 0 power. So x to the 0 power is 1. I'm going to write 8 times 1, bring down that plus 5. And when I simplify, 8 times 1 is 8 plus 5, and we'll get 13 for our final answer with that one. Now, another fun situation is negative exponents. If we have a number with a negative exponent, we can rewrite it a couple of ways here. Let's explore and look at that. So b squared over b to the third power is the same thing as saying b squared, that's b times b. All right, cool. And b to the fifth power is, we're going to write that b down 5 times on the bottom here. And we know that, okay, b divided by b is 1, another b divided by b is 1. We don't have any numbers left on the top in the numerator. We're just going to put a 1 there. And then b times b times b, these are the ones that didn't cancel out. We're left with b to the third power. Okay, that's one way to write it. Or if you use a rule that we had earlier, b to the second power over b to the fifth power, we can subtract those exponents. 2 minus 5 gives us a negative 3. So I have b to the negative third power. Now I can see that b to the negative third power is the same thing as 1 over b to the third power. So if we have a negative exponent, we can go ahead and move it to the denominator and make it positive. Pause for a moment and just look back at that and think about what that means. See if you can see the connection there. All right, so let's rewrite these problems with the negative exponents. 2 to the negative 3 power is the same as 1 over 2 to the third power. Okay, and again, we can simplify 2 to the third power and write 2 to the third power is 8. So this is the same as 1 over 8. That's fine. We can write it this way, the first way, or the second way. Next, we have negative 3 in parentheses to the negative 3 power. So that means I have 1 over negative 3 to the third power. And a negative 3 to the third power is a negative 27, because negative 3 times negative 3 is 9, and you take that 9 and multiply it times a negative 3, you get a negative 27. So there we are. We can write it the first way or the second way. Last couple of rules here. Power over power. If we have an exponent in parentheses and an exponent outside parentheses, we're going to multiply those exponents. So we're raising one exponent to another exponent. That means multiply the exponents. So over here, we would get x to the 16th power. Negative 3 times negative 4 is a positive 12. So we get y to the 12th power. And as we move further, the power of a product, basically, if we have two things inside the parentheses and there's an exponent outside, you make sure you distribute that exponent. Make sure you multiply that exponent outside parentheses times every exponent that's inside the parentheses. So basically, this 3 is going to make this 4 to the third power. And then we multiply 3 times 3 to get x to the 9th power. Remember that y is to the 1 power, so 3 times 1 is 3. And then also the z is to the 1 power. So I'm going to get z to the third power. And I can leave this like this, or I could also simplify what is 4 to the third power. But again, we're just focusing on the rule here. Now let's do this again. This gives me 7 to the negative 2 power, x to the negative 2 power, because we multiplied the exponents for both of those. And the last one, a negative 2 times a negative 2 is positive 4. So I have 7 to the negative 2, x to the negative 2, y to the 4th power. But remember, when we have a negative power, we can actually put that at the bottom of a fraction. So I can put 7 squared with the positive second power, and then x squared with that positive second power at the bottom. And then we would normally put 1 on the top, but we already have a positive exponent, so I'm just going to put that y to the 4th on top. Now, try out this last one here for yourself and simplify it. And just double check your work here. Multiplying, we can see we had 6 to the negative 2, x to the 12th, y to the 14th, and then 0 times negative 2 is 0. Remember, anything to the 0 power equals 1. So I'm basically saying all of this stuff at the front times 1. Let's move on to our last couple of examples here. The power of a quotient, very similar to what we just did. Basically, if we have an exponent outside the parentheses, we need to multiply the exponent times the top part and the bottom part, the numerator and the denominator, everything that's inside parentheses. So try to follow along and write out what these would be. Now take a moment and just double check your work here. You'll have some opportunities to practice after this.